Ladies and gentlemen, good evening. Today, I am excited to talk to you about a fascinating and groundbreaking concept in the field of artificial intelligence, generative adversarial networks, or GANs for short. By the end of this talk, you will have a clear understanding of what GANs are, how they work, and why they are so important. What are generative adversarial networks? Generative adversarial networks are a class of machine learning frameworks designed by Ian Goodfellow and his colleagues in 2014. The core idea behind GANs is to pit two neural networks against each other in a competitive game. These two networks are called the generator and the discriminator. How do GANs work? To understand GANs, let's break down the roles of the generator and the discriminator. The generator's job is to create new data that mimics the real data. Think of it as an artist trying to create a fake painting that looks like a real one. Initially, the generator produces random data, but over time, it learns to produce more realistic data through feedback from the discriminator. The discriminator's job is to distinguish between real data and the fake data created by the generator. Think of it as an art critic who can tell the difference between a real painting and a fake one. The discriminator provides feedback to the generator, helping it improve its ability to create more realistic data. The training process of a GAN involves a continuous feedback loop. The generator creates fake data. The discriminator evaluates both the real data and the fake data. The discriminator provides feedback to the generator. The generator uses this feedback to improve its fake data. This process repeats, with both networks improving over time. Examples of GANs in action to make this concept more tangible. Let's look at a few examples. Image generation. GANs can generate highly realistic images. For instance, they can create images of non-existent people, animals, or landscapes that look incredibly real. Art and design. GANs can be used to create new art styles by blending characteristics from different artists. They can also generate new designs for fashion, architecture, and more. Data augmentation. In fields like medical imaging, GANs can generate synthetic data to augment limited datasets, helping to train more robust models. Why are GANs important? GANs have revolutionized various fields by enabling the creation of highly realistic and diverse data. They have applications in art and creativity, generating new forms of art and design. Medicine, creating synthetic medical images for training and research. Entertainment, enhancing special effects and creating virtual characters. Security, generating realistic training data for fraud detection and cybersecurity. Conclusion and summary. Generative adversarial networks are a powerful tool in the field of artificial intelligence. By pitting a generator against a discriminator, GANs can create highly realistic data, opening up new possibilities in various industries. Whether it's generating lifelike images, creating new art styles, or augmenting limited datasets, GANs are pushing the boundaries of what is possible with machine learning. Thank you for your attention. I hope this talk has given you a clear and comprehensive understanding of generative adversarial networks. If you have any questions, feel free to ask. Thank you.